Okay, so I haven't done a video in a while, but I figured I'm about to put these things in, so let's go do a video on these before I put them in, or it's hard to kind of see and talk about these things. So these are the 6-element carbon fiber paddle shift units, and I've seen one person on YouTube post up a video talking through, showing what they feel like, what they sound like, but no one really talking through kind of everything that's gone into these things, which is a really cool piece of engineering. That's kind of why I have them. I'm not fast around the track, but I just like the engineering that's kind of gone into these things basically. So I was about to put these in, and I'm like, I should do a video, talk through this, and sort of introduce people to the concept before I put them in, basically. As far as the car's been going, the car's here. So you saw I ran around Pacific Raceways, posted that video. It's fantastic around track. Definitely, it's 286 horsepower is plenty for a new person to the track. And definitely the suspension and the brakes are what's almost a little more important, so you can get a feel for the car. You don't really need as much power because you're probably not going to be as confident taking those corners at super high speeds. So like for me, like on the main straight of Pacific Raceways, I was comfortable taking turn 1 and 2 rather, at around entering turn 1 at about 110 miles an hour. I was happy with that. I could push harder, but that was my comfort level. And if I had more power, I would just hit 110 and maintain up until turn 1, because I know that's my comfort level basically. So plenty of power, honestly, for doing that. Like a Type R, I know like someone who's experienced will hit like 135 or more on turn 1, and they'll maintain, and they'll hit turn 2 going in pretty hot. 110 was like my comfort level. I was typically doing like 100. So definitely the suspension, the brakes felt really good. No real brake fade. Got a little bit of, maybe it went a teeny little bit squishy on the initial travel, but it were tight after that. And tires were good. 16, we ran like 16K on these prior. This had plenty of life on track. You definitely feel like after maybe like the 4th, 5th lap, okay, I'm starting to feel just sliding a little bit more, which is to be expected with the PS4Ss. Right, these are Pi Super Sports though, but similar enough. And suspension felt fantastic. Within like 4 laps of, we're doing like ABS braking exercises in the morning. This is a class. Within about 4 exercises, I knew like where the right side and the right and left side of the car were based on pure feel. It talks to you a lot on track when you're driving it hard. So I'm super happy with that. Anyhow, I'm driving the car because a couple of weeks back this happened. So obviously collision, passenger side rare. So again, what happened was I was driving around and someone probably had a little bit too much to drink on a Friday night. And a wave wove into me. They didn't really dive the car, but they bonked the car hard enough to obviously cause some significant surface area damage to the side. So this is going to end up being a skin repair most likely. I'm working with insurance, I'm trying to get a hold of them for 2 weeks. They finally got back to me. It's going to be working through the insurance process, collision center, to get that fixed. So it's probably going to end up being a reskin. I don't know where the anti-intrusion plate bar is on this door, and I don't know whether it got hit. If it got hit, probably it's going to necessitate a new door. But insurance is taking care of all of that. Hoping that all works out pretty cleanly. The wheel got chowdered up a little bit as well. Granted, it is a $285 NK, so I'm not super worried about having to replace that. And the spokes of my current setup stick out farther than the tires, so actually the tire was pretty protected during that incident. The tire's fine. Car still tracks straight, doesn't seem to have impacted alignment or even suspension in any way. Just body damage, obviously. So not happy about that. I'm trying not to drive the car for fear of like rust or any other possible things. I don't know how deep any of this has gotten, so just not driving the car for a bit. Anywho, so I got sufficiently bored waiting for this thing. The battery's unplugged right now, because I'm trying to preserve some of the battery power. I'm still driving the car every now and then just to go through the gas, because I don't know when I'm gonna need to take this into the collision center. So I didn't put fuel stabilizer in it yet. Because I don't know when this is gonna go out. So I've just been disconnecting the battery, letting it sit for a few days, and on a couple of weekends, I'll plug it back in, drive it around for a little bit just to burn off the gas and keep the gas fresh. You don't want the gas to go bad and clog up anything. So just doing that every few weeks, basically. Anyway, I got sufficiently bored enough, the battery was out, and that allows me to pop the airbag out without getting blasted in the face with it. So I'm gonna do the paddles now, basically, just to have that moment. Anywho, so gonna talk about these. These are again, the 6 elements carbon fiber paddles. I feel like the name seriously undersells what these things are, because this isn't just, yeah, it's a carbon fiber paddle. However, this is a ground up redesign of the paddle shift unit. There are no OEM parts here. The only commonality is the connector. This is a ground up rebuild, not rebuild, re-engineering of the entire shift unit. These are using what we call magnetically sprung paddles. As in, there is no metal spring in there. It is only sprung by the fact that there's a magnet, which is this disc at the top, and a magnet on the bottom. That is how this thing is sprung. That's how it releases and how it snaps back into place. If you pop the magnet out, which I did by accident by putting them back to back, it would pull the magnet out and the paddle would go floppy, because literally the only thing that's springing this thing, that's holding it here, is that magnet. This is typically something you're going to see in like full-blown race cars, like TCR, GT class, Formula 1. I did Formula SAE in college, and we ended up building something like these. And the reason why I have this is really because I like the engineering that went into them. They were nice in college, and I kind of wanted to have at it again since someone was actually crazy enough to make one of these for this car. So I'm going to show you what the existing paddles look like and why these are different. But yeah, this is a bespoke, like literally a race car part. I'm going to say it. Like, that's what this is. That's why these things cost $375. They're not for everyone out there. Did it make you faster? Not really. Did it feel nicer? Absolutely. Did it reduce your ability to possibly miss shift? Absolutely. Because you're really not going to be able to miss, and I'll explain through why. Nature of my nails. But yeah, let's walk through and show what the existing sort of paddle units look like on the car, so you can go and see that. Okay, so that's your existing sort of paddle unit. So obviously it goes in like that. So that's the actual paddle body here, and it's just this little piece here that sort of compresses and does that. So it's hard to see. Well, you're probably not hearing my voice that too well. Anyhow, so that's the actual paddle. It's this little flat piece that just compresses against it. So obviously it's angled on the actual wheel itself, and that poses an interesting problem when you're developing a magnetic paddle. So all the extension is like the little silver bit, that's the actual paddle itself, and the extension just sits over here. So one thing you'll notice with these things is if you are touching the top of the shifter over here, sometimes you kind of dead spots, especially in this one, it's more towards the top where it's not super clicky. And the reason why is because if you actually take apart the shift unit, which the guy who engineered this has, it's actually, okay, if you're like into mechanical keyboards, and you know what a dome switch is, that's what's behind this thing. If you're not familiar with it, it's basically a flexible rubber dome that has to bottom out completely before it actuates. And obviously the dome's smack in the center of this thing. If you push all the way over here off to like this really bad fulcrum all the way over here, it doesn't always actuate. And similarly, depending on where you're kind of pushing on it, like over here, it's not firing. That's kind of barely firing it. So it does have a bit of a dead spot problem because it's such a short throw, and there's a dome switch smack in the middle that if you hit in the middle, yes, that's going to go off. Here, maybe not. So those are kind of your original switches that we're working with. I'm going to go over and walk through the sort of 6th element ones. Okay, so the fact that he got this working is actually, I find it really intriguing. It's like, usually with a race car wheel, you don't have an airbag in the way, and you're just going to have a straight plank of carbon, and then the paddle can just sit there and actuate in and out. This actually has to sit at an angle, so this is actually intended to sit like this in the car. This is sort of flat facing you, but the actual shift unit is sitting at like that 45-degree angle along the column. So the fact that he got this geometry to work, I find actually really interesting. So it actuates like that. So that's why it's kind of shaped kind of funny. This gooseneck geometry is actually really intriguing because that's a problem you usually don't have to solve with a race car, because you're just going to have that flat plank of carbon as your wheel. Anywho, so magnetically sprung, which means that there's a magnet here and there's a magnet on the bottom, and that is what actuates this thing. So there's no mechanical spring. So the idea is in there, You can kind of see the little piece of red. That is the actual switch itself. It's actually an Omron switch, so it's also nice and clicky on its own. But what you are hearing when I do this, that's not the switch. This is the switch. I'm gonna gently do it. Okay. That's the switch. That's not, that really louder clicky noise is not the switch. That is this thing bottoming out on the switch housing and then clicking into the metal, which is what you want. That's these things should be built. That's why this is a full metal housing. It has to be, to give you that kind of tactile feedback. It'll resonate kind of as it fires, basically. So the idea with magnetically springing these things is that, yes, you have that switch over there waiting to accept the paddle, but you basically need so much force to overcome the magnet that it's really hard to like half actuate it. Like I have to try kind of hard to do this. Usually you're going to build up enough force that's just going to fully drop. And obviously it's on one pivot over here, so it's kind of hard to half actuate this thing. That's from all the way at the top and all the way at the bottom as well. That's kind of the whole point of it. Like if once you get past the braking pressure force, it's going to just snap all the way down. When you let go, it'll just snap and click back into place with a magnet. So that's done right, honestly, which is very tactile. You can feel it when it's actually clicking. It's very positive travel and release. You can hear it too. You'll feel it in your hands. So that's awesome that they're actually doing that. It's done proper. The original switches are full plastic housing, which makes sense because there's a dome switch underneath there. But this is an Omron, and this is truly magnetically sprung with the metal housing, which is extremely important. So it's plug and play. The switch is OEM, the connector. So that's awesome. You can just stick these right in there. You have to pop there are plenty of videos out there on doing wheel swaps. That's basically an overview how to do this, which is what I'm about to do. I'm not going to talk about that. Let's talk about the cost for a little though. So this is a $375 switch module, not just a switch, not just a paddle. That's really expensive and probably not for most people, to be completely honest. And again, this is a bespoke race car part. Just how I treat it. Is that expensive for a bespoke race car part? Not really, to be honest. And low volume machining, they're not going to make a lot of these basically, so that's kind of why it's going to cost that much. Degrees in mechanical engineering, so I can definitely speak to like how much does it cost to actually make this thing. Paddle is water jet carbon, which is how I would do it personally. I don't see a point in molding carbon for these things. That's kind of excessive. So yeah, this is water jet carbon fiber, which makes absolute sense. It's really straightforward to make. It's really cheap to do. It's economical, and they can cut into whatever shape they want. It's really fast to do. All the cost goes towards machining on this thing. There are 1, 2, 3 parts. It is the bottom cover, the main body, and this arm. Has 3 things to make on a machine. Typically, 6061 isn't super expensive. I don't know the cost off the top of my head. It could be more like 20 bucks, like 30 bucks, like raw material for these things. Machining time for a multi-axis, which these definitely require to do this shape here, usually runs about $70 to $150 an hour for time on the actual machine itself. And that's multi-axis for potentially, well, this is probably, you could do this on 3 axes, just refixture it. Same for the one at the bottom. I haven't taken this apart, not quite sure. The body definitely required multi-axes. So got 3 components you got to make, and $150 an hour to run the actual bots, not including raw material. That adds up, and that's kind of why this starts to run into that $375 range when you factor in engineering time. In fact, you got to pay the guy who designed it and a little bit of profit margin. That's why it costs that much. This is why for the paddle extensions on my car right now, 60 bucks makes sense for something like that. It's a single operation, 1 part. This is like 3 that you got to make. So that's kind of why it costs that much to do. It's machining time that really destroys the price in that respect. Also, like there are little things here they could have. I'm just amazed that it actually machined out. Like that little lip there, the little clips. That's nutty that they actually machined that. That takes so much time to like nail right. Honestly, it's such a tiny feature. And also thin wall machining over here. I'm impressed the machine shop actually agreed to do it. Well, they probably would agree to do it for the price. But I'm kind of impressed. That's, yeah, thin wall machining over there. Tiny clips over there, And I mean, multi-axis that's not super surprising that I ended up needing to do that. Little radiuses everywhere on this thing. Well, I mean, that's expected with a ball mill. Yeah, it's the machining cost, which is why they cost that much. So not really worth complaining about in my mind. The paddle extensions are perfectly fine for street driving. I like these because I like the engineering behind them, and they're a little bit of a marginal gain about like, hey, you're not going to miss your shift on track. If you're going full race car, this is what I would expect, basically. This is what TCR cars have. This is what your GT cars, F1 cars kind of have, basically. But yeah, I think I'm running out of space on my phone, so I'm going to cut the video here. Let me know if you have any questions. There's other videos online of people showing people clicking through them. They sound really awesome. But yeah, let me know if you have any questions on that.